like to introduce you to Alan Toole. So Alan is an advanced certified Scrum Master and principal quality assurance engineer at ADP. He has had the opportunity to influence the transformation of large enterprise companies, maturing their Scrum practices, and increasing test automation coverage. And Alan has written several automation frameworks at multiple companies in the Atlanta market. And he comes to us here today with a passion for teaching and knowledge sharing. And his other passions include playing guitar, gardening, and spending time with his family. Welcome, Alan. How are you doing today?
I am doing well, and thank you for that kind introduction. As you were speaking, I was looking around trying to see what you were talking about. I am very excited to talk to you today, and I want to thank Bibu for giving me this opportunity. I put together these slides that I hope will help you to kind of see the picture at a high level, but then see how it should converge at the lower levels. So the first thing we're going to look at is an assessment question. And then we're going to look at then how do we move from one level to the next, and you'll understand more what I mean by that when I get to the next slide. We will look at some possible things to look at from a process perspective, followed by now looking at how do we actually build a testing strategy. So the first question is, where's your organization, department, or team on the capability maturity model? Using Carnegie Mellon University Software Engineering Institute capabilities maturity model, we'll orient ourselves as an organization or team. The Department of Defense undertook a study to identify they took a study to identify the criteria that made software more effective, and this research was conducted by Carnegie Mellon University. The end result was an algorithm that enabled the DoD to identify a more effective and efficient software development. The algorithm is now known as a capability maturity model. In that model, what you find are these levels. Where is your team when considering level 1 through 5, shown in this slide? Are you level 1 in an ad hoc type of environment where managing people is the mode of operation, leaving individuals attempting to convince their manager of their superior work performance? This level is where you'll feel politics is very significant, and an emphasis will be on meeting predetermined schedules. Or are you at level 2, process control, where you have controls in place, you've established processes, but now you're in the process of actually training and helping people to follow those processes? Or level 3, where you have core competencies, which has to do with understanding capabilities and being able to manage to those capabilities. This is where your teams become more focused. Mentoring is very common. And then this is where you're looking for the skill sets that are needed in order for you to be able to address those core competencies. As you develop this particular phase, you may have to go back and re-engineer some of the processes. And then level 4 is where things are predictable. This is where you're now managing based on metrics by fact. Results are predictable, and coaching is much more common. And then level 5, this is basically you're an elite organization. You are now at a point where you're doing benchmarking and you're setting industry standards. So how do you go from level 1 to level 2? Moving your team from level 1 to level 2 requires defining definition of work processes, training team members on using those processes, and then having discipline and controls around those processes. Someone may ask, isn't one of our core values as Agilists, where we say we come to value individuals and interactions over processes and tools? I think a way to think about this may be that individuals and interactions in the past were not emphasized or having high observance in the work setting. I remember my days back at AT&T where you had your cubicle and you were given your assignments and you basically just worked in a silo. And then you had a walkthrough or whatever, a walkover is what we started to call them. And that's when you started those interactions. So most of your interactions were in more of a formal setting of a meeting versus on the floor interactions. So when we think about processes, there are processes that are needed. And if we are not aware of those processes, we end up having to re-experience the things that we went through prior to having those processes. Processes were emphasized primarily with limited individual interactions. So we need processes, but we also see that there's a great benefit and value in having individuals that are purposely interacting together. If you are at level 2 and you need to move to level 3, then what you want to do here is you want to focus on developing core competencies. Core competencies are going to be things around the technology that you use in your application, as well as the tooling that you might need for testing and other ways of managing and monitoring your application. So if you think about the DevOps side in terms of ways that things are going to be monitored, how many organizations actually think about whether or not they have trained individuals, or do they just hire people expecting them to come in with those skills, even though that may not necessarily be a skill set that they were trained on prior to coming to that company. Training is completed, leading to empowerment. And when people feel empowered, they are more inclined to want to follow your processes. So training is a very key thing. If you're at level 3, then now you want to move to level 4. This is where quantitative standards are being developed. These include the metrics that are tracked across the tech stack. Also, you're now developing dashboards. These dashboards are used by management so that they can use these standards to actually manage how the organization is performing. In the interest of time, I purposely left out moving from level 4 to 5. So we'll continue. And now let's think of what are some examples of things that you might want to consider having processes around. One of the things that I find in a couple places where I've worked is that we tend to want to spend less time collaborating sometimes about things like this. And we want to rush through some of these events. But the requirements definition, when we're doing backlog refinement, that's taken the place of in the waterfall method when you started off a project and you went through a requirements phase. In that requirement phase, you're trying to determine everything necessary for implementing that particular product. Where our backlog refinement is where we have to do that now. And if we don't have our teams work together and really understand the benefit and the reason why this is so necessary, we can lose the benefit from having this because of that. In other words, developers are fine with you giving them a problem, and then they go and try to figure out how to solve it. But the challenge that you have there is all of those insights that they're becoming aware of is not being shared across the team. And so if we are developing requirements together, then we get a shared view of what the requirements should be. The estimation then is another activity in the backlog refinement where basically we're pointing out stories. The testing, this is also an area where it seems that we tend to think that if we have a person that we call a tester on the team, then we just kind of leave that up to them. But that again becomes a problem because the ideas around this collaboration about having all this interaction is that you get these shared perspectives. And then you start seeing different priorities that now need to mesh together. So it becomes very important that we have these things as part of the process, which they are, but we have to make sure that that part of the process is actually functioning the way it is expected to. And then we have the system maintenance part, which is basically your sprint, your development. That's basically your sprint. So this is where you're developing the code. This includes creating the automation and all of those things to support what you're wanting to deliver. Now, the last thing I'll say about this is that when it comes to requirements, you know, it is very important that teams understand that requirements need to be fully understood by the team itself. Otherwise, you'll end up with conflicts between developers, which are things from the past. And if we've not determined what the scope is when we talk about what is the definition of done, the acceptance criteria, if we haven't established that up front, then what we end up having is churning once that handoff to the tester happens, and the tester is thinking about it in a different way than what the developer is. So this information gathering and sharing around the requirements is very important. So test strategy. Test strategy is basically when you have test scope plus test resources. We have a testing strategy when we have determined our testing scope along with the resource required to execute it. Having experience both in manual and automated testing challenges, we have to have a better way of determining testing scope in order to minimize pitfalls from the past, which could include having duplication in test cases due to how test cases are written, not having sufficient test data to handle more exhaustive test cases, automation that takes too long to run, automation that is flaky due to the instability in the application. These are things that happen and they continue to happen. And I believe that the reason these things continue to happen is fully because of the fact that we don't take enough time to focus on a testing strategy. Most of the time we approach our development focused on the development and trying to get the product developed as it relates to writing the code. And what happens is these things, if they're not accounted for in our sprints, in our sprint planning, if we don't account for these things in the process that we follow doing Scrum, then what happens is these things will automatically cause us to have challenges that have always existed and will continue in our organization if we don't choose to act differently. So how do you decide on the testing scope? Is it necessary that the PO and developers, which includes the UI or web services or backend developers, weigh in on what is tested? In other words, should they give input on that? And the obvious question is yes. And the why is because of their insights, because of their perspectives that will give a more holistic understanding of the feature. A lot of times, again, we can have developers who want to just go off to themselves and write code. And if you are working with a team or a group where that has been the mode of operation, that's one of the mindset changes that you're trying to address, because they truly believe that that is the quickest and the fastest way for them to get work done, is to just go off to themselves, not be disturbed, and work on it. And unfortunately, when we allow teams to continue to work like this, we are basically working with the same type of mindset that we worked under the waterfall methodology. The only difference is we've changed what we called it, and we've put it into these different ceremonies where we're still thinking waterfall. If you ever are on a team where they say, well, you know, we'll test it in the next sprint, that's a waterfall mindset. If you're ever on a team that says, you know, after the end of the quarter, we're going to do a regression test, that's a waterfall mindset. Therefore, we have to lead to create a more valuable test. how do we create a more valuable test? It is just as important to decide what to test as it is to decide what not to test. And why are we trying to do that? One is because we don't want to get our repo bloated so big until it's hard to manage, or running so many automation tests that it takes days for them to run. So we have to be thinking proactively about how are we going to keep our environment, our infrastructure as it relates to testing, how are we going to keep that environment lean and very effective and efficient? If the developer, the QA person on your team, is the sole determinant of what is tested and automated, then you may end up with lots of tests leading to long-running automation. Test execution, which leads to more opportunity for failures due to resource consumed by the local machines that they run on, and or instabilities that may just flare up in the application itself. So the team during the backlog refinement should discuss what will be automated and what will be manually tested. This is where the fun begins. If your team is not accustomed to doing this kind of an evaluation, then the Scrum Master will have to be patient and schedule a session to work slowly through this process. You start by having a scale of 1 to 5, and then you look at the value of the test. What you're looking at when you're trying to assess the value is the importance of that feature, which the product owner should be able to provide that perspective from a business perspective. You're also looking at the probability of fixing that issue if it breaks in production. In other words, part of the value is if this feature that we're trying to decide what to automate, if it broke into production, would this be something that we would try to address immediately? And then how distinct is the scenario? When we start thinking about the test scenario itself, if you consider perhaps if you were writing a test for a shopping cart, you may have a test that adds 1 item to the cart. You may have another test that adds 4 items to the cart. Well, the item that adds 1 item to the cart is sufficient. The second that adds 4 really is not very distinct from the first. So that's what you're looking at when you're looking at tests, is you're trying to figure out the minimum that you can write that sufficiently will test that feature. And sometimes some of the little bells and whistles that we add on by doing a couple additional things is really not causing you to execute any different code underneath. So that's where you have to really be thinking about that when you're writing tests. Another way is to also involve using different testing techniques. For instance, you may have heard of boundary analysis, where you look at different boundaries for a value within an input field, and then you choose to use things based on those boundaries, upper, lower, and something in between. Or equivalence partitioning, that's where you have a set of values, and any value from that set will represent the full set. So what you're doing by doing that is you're not having to write a lot of cases with different data combinations when one value from that set will cause you to execute that code. Then there is risk assessment. What are we trying to do in risk assessment? Well, what we're doing here is similar to what we do when we have bugs that happen in production. We're trying to establish how severe is that item. And so it goes back to how is it going to impact the customer, what's the probability of it happening, and then how often are they using that feature. If it's something, it could be something glaring, it could be something that's somewhat just annoying, but everybody, when they go into the application, is going to have to interact with that. And just because of that, you may choose to have a higher severity than something else. So those are the things that you want to consider when you're trying to establish the value of a test. On a scale of 1 to 5, 5 meaning it has a high value 1 minute it has a low value. And then we get to the cost. So how do we determine the cost of the test that we're going to write? And I also want to clarify here, what we're now thinking about when we're talking about test cases, we're talking about test cases that we're going to automate. So when it comes to cost, we want to understand how difficult is it to perform the actual test. And then we want to think about how difficult is it going to be to actually write the test. So if it's very easy to perform that test case, it gets a higher score. If it's easier to actually write that test, it gets a higher score. One thing that I've seen happen with automation is where people will write a script that may take 20 minutes, 30 minutes to actually run as an end-to-end scenario. And what that says to me when people do that is they did not focus in on the unit and the components enough so that they could be comfortable not having to try to write a test that's going to be that complicated. Because tests that are written like that, one is that they do take a long time to run, and two, they have a higher probability of failing just because of something that's system related but not code related. Whether you are new or on a new or an existing team, you have to pay careful attention and to these areas because they are strongly, they can have a strong impact to how things evolve over time. So having the proper data for testing, a lot of times this is something that's overlooked in the beginning. And what happens is when we haven't really thought about the data that we need and the complexity that might exist because of that data and try to address that up front in terms of our engineering, we end up having to try to deal with it on the back end. We also end up writing tests that are too data specific until it's hard for us to change the variations so that we can actually have more test cases. I worked at a company where it was basically allowing people to purchase insurance online, and it was for small businesses. So even though the application in terms of the navigation was the same, if you were a landscaper versus a massage therapist, what you would see on the pages would vary based on the type of business that you had. When I first came to work in that particular setting, I realized that that was going to be a very difficult thing to manage. So we immediately decided on how we were going to deal with that. And we came up with an approach that was actually quite successful. We were then able to run tests and add tests simply by adding data. We could literally write test cases for multiple business types simply by adding the data. Our automation framework was written in such a way that it was able to determine what to interact with on the page based on what was in the data itself. And because of that, when we went to production with that system, we had very few bugs. As a matter of fact, one of the bugs that I remember that happened was an issue that we were seeing during testing that never got addressed, that was tied to the login. And then eventually it got addressed in production, and it turns out there was a design flaw that had to be addressed. But the automation was actually given insight around that issue very early on. The development team chose to ignore it because of the fact that it wasn't going to be an easy fix. The tooling, we have to think in terms of what kinds of tools we want to use. You think in terms of like for test management, a lot of times organizations, if you're not in an organization that hasn't had the benefit of test management tools, then chances are they are basically trying to use Jira or Bugzilla or some other tool just to try to manage that. So with the automation and with the pace that we want to go with now, it's very important that we try to find tools that are more comparable and will give us the functionality we need so that we can give the proper reporting across the organization and across the different testing platforms by which we might be testing. Security testing, browser testing, including accessibility, load and performance. These are the things that we should be talking about upfront in the beginning and making sure we have, again, going back to core competencies, making sure we have the right people who understand these things, have that training so that they feel empowered and they can use those tools for maximum efficiency. Then we get to classifying tests. So the next thing we want to do is start looking at then how do we classify tests based on the different aspects of our technology stack. And so the next slide we go to, we'll be looking at an agile testing quadrant as well as a testing pyramid. You may be familiar with these. So first, I want to draw your attention to Q1 and Q4 quadrant. And what you'll notice here is that there are technology-facing items that either guide development or critique the product. These are tests that are not seen by the business. And so these are the things that really are focused on how we develop and how we monitor and or critique the performance of the applications. Whereas quadrant 2 and 3 are business facing and guide development and critique the product. These are tests that inspect and assess what the business will see and experience. Q1 includes your unit tests, your component, your integration tests. These should be the fastest tests. This is where having developers write unit tests becomes critical. I've known of groups where they only wrote unit tests and they basically had a system that experienced few issues. It's not the recommended way, but if we're testing the right things at the right time, it does mitigate a lot of issues getting into production. Q2 includes UI tests, both manual and automated, and should be reflected in your definition of done. So this is where in our backlog refinement, when we're going through clarifying, this is where we decide what is going to be tested. This is where we go through that approach of determining the value of tests and whether or not we're going to include certain things in our testing or not. Because if we don't, again, we're going to have some of those other problems of having a bloated repository, having tests that run forever, and things like that. So it's very important that we pay attention to that. Q3 includes mainly manual tests to inspect the current state of the application and observe that is observed from a user's perspective. Q3 is basically where you might consider where you have user acceptance testing. Also, anytime you're doing a deployment, when you go into the environment just to check it, this is like kind of going around kicking the wheels, making sure that things are hooked up and connected. And then Q4 includes all of your automated tests that are basically for gathering metrics and or checking security threats or load performance kind of stuff. These are all of those types of tests that now you're making sure it's getting orchestrated and prioritized. Being aware of how test types and the purpose they have, we can now use the previous approach and determine what tests are created by having coverage in the quadrants here. So as we are looking through this quadrant, what we're trying to do is determine first what tests will have the most value, and therefore we would include in the scope for the testing itself. Now, going back to the assessment of your organization or team, we can now consider how our current state is represented in this pyramid. In other words, are you in an organization that's heavy on unit tests, but perhaps a little light here? Or are you in an organization that's just heavy on UI tests, automated tests, and nothing here? Depending on where you are, this shape could be a square, it could be inverted, upside down, but this is where you want to now start to use your insights to try to create an environment that's more ideal. What you notice here is at the bottom, these are more isolated tests. The further you go up is where you get your integrations. And what that means is if you're vetting at the component level, at the unit level, and you're getting the proper responses or results, then as you go further up, it's going to be less likely that you experience issues. And when you do experience issues, it's generally going to be that integration piece that's failing. When I worked at one client, the first thing that I did was write tests for services. And using that data approach that I talked about, we were immediately able to run over 1,000 tests after that particular sprint. But what it did for us, between our UI and our web services, there was a integration layer that would translate things on the UI before it passed it to the back end. What that allowed me to do, if I saw a discrepancy in the UI, I could immediately run that same test case at the web service and to see if I got a result there that was failing. If they both failed, then I knew there was an issue with the business rule itself. But if the service passed and the UI was failing, then I knew there was an issue between the UI and an integration. So what that did is it gave me more information for the developers, because if developers don't have enough information to address a problem, it's going to take them a lot longer. And most of the time, it'll just get pushed to the side, depending on what organization you're with. On the right side, what you're seeing is that at the bottom, these are your fast tests. These are the ones that you can have in your pipeline so that when you do a deployment, you can run these tests and you can have some assurance that nothing should be breaking. When you get into the integration layer, that's where you're checking for that connectivity. And then you might have some tests that run at the UI. But again, you're trying to make sure that you can run these tests in a very short time period, and that they're not going to fail just because of how the test is written or because of some other factors that have nothing to do with the code itself failing. Okay, let's see. All right, so that covers what I wanted to share with you today. I guess we're now at the point where we can start having questions, and I'll just tell you up front, if you are a Christian and you ask me a question that I don't know the answer to, you will lose your salvation. That was a joke. But anyway, back to you, Lindsay.
Thank you so much, Alan. That was a great presentation.